Welcome back to In Depth with Academia. This is Richard Price, CEO of Academia IDU, and I'm here to walk you through an intriguing new piece of research. Remember, I'm presenting it as neutrally as possible. I'm not endorsing any claims, just shining a light on fascinating academic work so you can decide what resonates or inspires further exploration. So today's episode is all about Sundaland and ancient sea surface temperatures. Yeah, that's a mouthful, but stick with me. The paper we're looking at is Holocene and Deglacial sea surface temperatures in Sundaland by Dani Irwanto. Let's dive in, or, well, wade, since we're talking about continental shelves and sea levels. During the last ice age, it was actually above water, understanding how sea surface temperatures evolved here, especially as the world got warmer and sea levels rose. Well, that helps us figure out not just climate patterns, but also things like ancient migration routes and the broader triggers of environmental change. I mean, think about it. What if a few degrees of ocean warming drove massive cultural shifts? That's kind of wild, right? So Dani used a pretty high-powered method for this work, tapping into what's called the Last Glacial Maximum reanalysis, or LGMR, picture over 700 different ancient climate records, all kinds of stuff like sediment cores, ice data, you name it, plugged into this big global model. The result, we get a timeline of sea surface temperatures for Sundaland averaged every 100 years from about 22,500 years ago right up to now. The focus was on two main slices, the whole Sundaland shelf and this tight intertropical belt, basically right around the equator, plus or minus 6 degrees latitude. That way, Irwanto could compare tropical core ocean temperatures to the broader region. Pretty clever. So what pops out of all this data? First, there's a big warming phase after the last ice age, which you probably expected. But it's not just some slow climb. It turns out the coldest water temperatures in Sundaland actually lagged behind the global cold peak by like 2,000 years. Usually we look at 21,000 years ago for max global ice, but here in Sundaland it's more like 19,500 years ago. Why the lag? Maybe slow ocean mixing, maybe greenhouse gas pacing, maybe something deeper, pun intended. Then, here's something neat. There's a pause in the warming trend around 14 to 12,000 years ago, which lines up with the Younger Dryas. Now, if you haven't heard of the Younger Dryas, it's basically this sudden cold blip, even as the world was supposedly warming up. The interesting twist in Sundaland? That pause happens earlier than up north. Regional quirks and feedbacks might be to blame. Oh, and you can see a delayed warming peak thousands of years later, around 5 to 3,000 years ago, after the rest of the world already had its hot spell. What does this mean for us? Looking back, or even forward? Well, for starters, it's a reminder that climate change isn't uniform. Regions can be out of sync, maybe by thousands of years. So if you're thinking about, say, how rising temperatures might impact Southeast Asia in the future, these kinds of case studies say, nuance matters. You can't just borrow a timeline from Europe or North America and expect it to fit. Another tangible finding, the equatorial slice, that intertropical core, held steadily warmer temperatures than the rest of the shelf by about 0.5 degrees Celsius. That doesn't sound like a lot, but wow, across millennia, that difference can shape monsoon patterns, rain belts, even whole ecosystems, or, just ruin the beach day for some ancient elephant, I guess. It's amazing to imagine what used to walk those now sunken plains. Oh, before I go on, quick digression. I once read a novel about Sundaland being an ancient lost civilization, kind of like Atlantis. Do you ever wonder if there are still temples or ancient camps under those waters, preserved for tens of thousands of years? Anyway, back to the research. See, even I get sidetracked thinking about how climate history crosses into, human storytelling. Just to be clear, the paper doesn't claim there was a lost civilization under the Java Sea. It's focused on reconstructing temperature changes using big, synthesized data. Again, I'm not endorsing any storyline or alternative history, just presenting Dani Irwanto's research for your own reflection. So wrapping up, what can you really take away from this study? I'd say 3 things. First, ancient climate events played out differently across the globe. Timing, impact, all of it. Second, understanding those differences gives us important context for how today's changes might unfold in diverse regions. And finally, academic research, like this, isn't about reading a crystal ball. It's about piecing together evidence, asking better questions, and inviting all of us, yes, including you, to be curious about how our world works. That's it for today's In Depth with Academia. Remember, every paper is a starting point. Nothing is final, and the conversation is always growing. If you found this topic interesting, maybe dig into some paleoclimate data yourself, or just reflect on how the past keeps reshaping our view of the future. Thanks so much for listening. Until next time, stay curious and keep questioning.